Looks like it started. So, hello, I'm Proctor. I'm up here in North Texas in Dallas Fort Worth area. Recognize a number of your faces from past groups because I'll pop on occasionally. And I know some of you have presented here and some of you have seen me talk about some other stuff. So, I've been doing functional programming and got into it back around 2010 and exposed. So, first exposure was Clojure, then had done some Erlang, played with some Haskell a little bit just to play with. I've done some Elm, but recently, in the past 4 years or so, I've gotten into full-time Clojure, and so going to give a talk a little bit about Clojure.SPEC. And when you hear a lot of people talk about Clojure.SPEC, you hear about the specification part. So I'll run down that a little bit and using that for essentially validation checks and such. But the other part is you can use spec for essentially parsing your code and parsing your data structure and getting essentially a parse tree out of that instead of you having to write the parser yourself. You can do validation and you can do parsing with it, which leads to some interesting behavior you can kind of squeeze out of that as well. So uh that's me and a little bit. So I can start sharing my screen and I'll give a brief rundown of some Clojure as we go through it. And because I know not everybody is necessarily familiar with Clojure in detail. And let me see if I can keep the chat window open in this other screen. Chat window. Okay, so again, I'm treating this as a fairly interactive session. So if you have questions, feel free to chime in. Sounds like there's only one over at Pros, so no need to relay the questions if there's audience member, but feel free to ask and chime in, and I will try and explain. I know not everybody is as familiar, but I'll try and give a rundown. So there's Clojure.SPEC, and that is part of Clojure core. So it ships with Clojure, but it is a distinct library that you pull in, maintained by the Clojure core team. And they have also a library of Clojure core specs alpha. So you can, as part of pulling in specs, you can actually get these specs for the Clojure core functions. So here is just an example namespace, and I've got this in a repo structure. I can push up to GitHub for some demos, and so we can share. I'll share it with Claude later, and we can kind of go over that. But just a basic Clojure. So Clojure is a Lisp, and so Lisp has two parts. It's got the read part and the eval part. So there's some reader syntax that allows you to do some stuff. So if I just say I have foo, it says I get an unable to resolve symbol foo in this context. So it's a symbol there. It's not bound to anything, so it can't find what it's supposed to be. If I want to just refer to the symbol foo without actually trying to find what its value is and get the value out of that, I can put a quote in it, and a single quote beforehand is short for quote foo. So there's a quote form and there's a reader shortcut syntax. And quote is essentially enclosure and other lists that say, I've got something, but don't try to evaluate this. So I'm going to give you something, but because Clojure has the same form of its data as its code, which they talk about homoiconicity, meaning it's the same data that is your code. You construct a list looks like 1, 2, 3, but that's also the same structure function call. And you see the linter here says 1, a number is not a function. So I can't call a function 1. So if I wanted that to be treated as a list without trying to be a function call, I have to quote that list. And then I can get that back as a list and have it read in as a list instead of trying to read that list in as a function call. So there's a couple syntaxes here that I could just have. So there's different ways of quoting it. So you can quote the list, so don't evaluate the list, or I can quote the whole thing, which will quote the symbols inside of it. So if I select that, we can see it evaluates X, Y, and Z symbols without actually trying to get the values out of them. So there's a little bit of syntax to start with. Just so as I go over this Clojure.SPEC stuff, there's some details here when we see some of this stuff. So Clojure.SPEC, most people know of it for validation and putting specs around your types. So keep it separate than your types, but you can actually put specs around and start to use things. And then there's things like you can do generators eventually and things like that. But it says, hey, I can give essentially a validation function around this kind of stuff. So I can say, hey, spec, I've got spec alias to S, so I don't have to type out the full namespace, but I can say inside the spec namespace, there's a function valid, and I can say, given a spec, is this thing valid? So when I evaluate that, I can say 124 is a string. It is valid that is a string. If I ask, is 3 a valid string, I get false back. Not surprising. I get nil. I can ask about different kinds. So is this a list? Yes. Is this a list? Yes. And I'm not trying to evaluate X, Y, and Z. I'm just got a list of symbols that are X, Y, and Z. There's all kinds of different functions in there. Valid. And spec does some stuff where equals 0x. So I can put a one argument function that gives me a true or false return value, a truthy return value or not. And I can check that, is that valid? Or is this valid? So I can just say, hey, I've got this. And so it can take a predicate that you want to do. And you can start building out from simple predicates, more complex details. So that is part of the stuff. That is the simple side of validation when it comes to spec. If something is not correct, spec has a explain function as well that can say, hey, this thing's not valid, but tell me why it is valid or not. So I can explain the fact that I've got a string and it says it validates its success, but there is no value because there's nothing to explain, it passes. If I explain string, it says 3 failed the check of string. In this case, it's a simple predicate, so it just tells you why did this thing fail. So you can, if you have some questions about like, why did this validation fail, or which part of this validation of defining a spec failed, I can start to ask those questions. So that's some of the basics. That is some of the basic syntax of spec at the high level. So I can do spec also has a def function, which means I can define.
Sorry.
Yes, go ahead.
Just a quick question about Clojure, and this is just because I played around with it just barely. But so when you get that output, is it logging that explain to like a standard out, or is there like it's not returning as a like a function would return, but could you capture that like in code or like in an error or something like that? Or would you have to pipe the output into a variable or something like that?
No, there is explain data.
Oh, okay. Yeah,
so
sure,
I can get explained. I can do explain data as well.
Oh, very nice. Okay. So it's just a print loop in this case. It's just a print statement.
Yeah. And some of this is from me evaluating it in the REPL and saying, look, I could say, hey, Clojure.SPEC alpha, here's the problems. And we'll go into this a little bit more, but it says, how did I get here? What is the path? If I have a more complex structure, what was my path to be able to get to where the validation failed? This path is empty because it's just the top level, and it says, hey, I'm checking the predicate against Clojure core string with the value 3. And what is my spec? And then here's my spec that I'm using. Here's my spec that I'm using, which is function Clojure core string, and I gave it the value 3. So you can start to see this kind of stuff. So then and if you want it in a nice explain string, can say 3 failed string question mark. So
Nice.
it can, and you can pipe some stuff and put some output stuff to somewhere else if you wanted to. But yeah, you can start to get more details, and we'll see some of the stuff with part of by giving you the where and the path that it found problems and things like that.
And is that 3, that value, is that like an enumeration of errors that could possibly go wrong with string, or is it?
This is the value it failed on. This, I
Oh,
believe,
okay.
on
Yes,
is
very
the
good. Okay.
value.
No, no. Yep.
This is the
Yep.
value
Makes
at.
sense. Yep.
This is the value that got in at the root, and then here at
Okay.
this path, here's the value we found and what it failed on.
Okay. So if you had like some kind of recurse, okay, that makes
Yeah.
sense. I
So
was curious. That's cool.
so now we can define a spec, and we can. I think I have some examples. If not, I'll cover some more details of this. Uh, Again, that's why I said this is kind of interactive. So ask your questions. If I gloss over something in Clojure specifics, feel free to ask those too. Uh, I've known a number of you from this group for off and on for a couple years through the group, so I'm not shy about stopping and answering your questions. So yeah, so I can define a spec. This colon, what is a Clojure shortcut, but what it wants to do is every spec is a keyword, is tied to a qualified keyword. So there's namespace keyword. So in this case, I'm in the spec demo namespace, and then I can say non-blank string. So one way of writing this keyword of colon non-blank string, and if I evaluate that, by evaluating it, we can see that spec demo, which is the namespace we're declared in, non-blank string. So this part is just some essentially Clojure reader syntax for give me a keyword, and a keyword is like a symbol in some other languages where it's something that evaluates directly to itself. It can also be used as a function in certain cases, but the idea is that if I'm going to give a spec, when I define a spec, I'm going to give it a name, but that name really there's some context to where that name of that spec lives. So I might have, and there's a couple talks for if you're curious on spec. Rich AK has a couple of more talks, which is speculation, and then maybe not, in which he talks about some of the problems with this first passive spec, and they're working on a spec version 2 to come out at some point, but they're working through it. But the idea is that in some of those talks, they talk about like you might have multiple identifiers about you. And if you think of that in a open record format, for like OCaml has extensible records, I believe, or maps enclosure, which is the idea that it's an open map. There's keys we care about and keys we don't. We can say that I might have something in a namespace of work slash some kind of namespace about work with an email under there that is an email, and I might have some other kind of namespace of work, home, contact info that may have an email or a cell phone number. And so you can say this is, in this case, this is what a email looks like because you're working at this thing. There's a format to it. Oh, neovim.files. I'm using Conjure in neovim to do the evaluation of my list forms to get a reader. I see those comments.
Uh, dot files, Proctor, in GitHub or somewhere. I'm really curious. I want to set up something similar. My NeoVim similar. Mine is not as perfect as yours. If
So
you have and could share that, I would be glad. Thank
yeah,
you.
my dot files are there, and I use Conjure, and they're not quite neovim dot files. The person who did Conjure has worked on something called Aniseed, which works with being able to write fennel, which is a Lisp that compiles to Lua. So I've kind of went the Emacs route in my Vim files. and expressed everything as a Lisp. So just be warned if you want to look at my dot files.
Yeah, okay.
But so what I can define is I can define a non-blank string. And what I do is I define that in this context of spec demo. So that's part of the important thing, is that when you have these specs, to avoid name collisions like you would do anything else, you have a namespace that identifier corresponds to. So that's what this : non-blank string means. It's the same as this, which is the namespace. We're in line 136. So here, namespace spec demo. It uses, as we saw, it evaluates the spec demo non-blank string when we look at the double. But so the def takes a qualified identifier keyword, and it will creates a registry, and that's how it does it to help avoid collisions and clashes. So there's certain spec functions. So there's things like spec and. So I can start to add multiple conditions that spec can evaluate. So I can say this is a string, and essentially it's not blank. So I can define a spec that's a non-blank string, and I can say, and then I can validate not just a function, but I can evaluate a keyword, namespace keyword. And so it'll look it up in the registry, figure out what the spec definition is. Make sure I evaluated that. Helps if I get my keys. Okay, so it did evaluate. So I can then validate and say, hey, is this a non-blank string? Is stuff with white space at either side, but still some stuff in the middle, is that a non-blank string? Is something with a bunch of empty spaces in it a non-blank string, and it says it's false? Is a nil false? So I can start to compound and give extra pieces, and then that's one example. There's another example I have here that says I can do ors. I have an and, I can do an or. An or for Clojure.SPEC is slightly different, and I need to give, because an or takes multiple paths that you can go down, we can say, where did this fail? So I can say, or I can say it's a non-blank, and then give it an identifier. So it's a non-blank string, and then use the spec of non-blank string, or it's an identifier of number, and it's a number. So I can have a new spec that says, you have to give me a non-blank string or a number. So I can do this, and I can say true. I can say evaluate 1, 2, 4. But if I go with a Clojure vector that has a string, it is false. And then when I want to explain data why that failed, we can see here's two. Now this goes back to what Chris was Chris was kind of getting back about, how do I get data about what failed? Is I can see problems. I have 2 problems. Because here's a list. So I have a path of non-blank string 1, 2, 4, and a vector of 1, 2, 4 did not match the string. I also had the path of number, which it failed, and the vector 1, 2, 4 was not a number. I can also I get nothing out because it validated. So now I can start to give richer stuff and start to understand where and how did this spec fail. So if I have multiple conditions, because it's branching logic, I need to know which branch I went down that helped cause the failures. So that's what the or does with having a keyword in front of it. It helps identify which branch I went down. So there's a few other things that I'll give some examples of. I can do def, and I can do I can define a spec for my vector, and I want a specific structure to it. So I can do s.cat, which gives me a sequence. I want to expect something as essentially a list of values. So I can say cat, I want a name, I want a number. And I want so I can say I have a my vector and I want to know if vectors so what this cat does is it starts to give elements to a sequence that I want or I expect. So I expect the first thing to represent a name, the idea of a name, the second one to be a number and give me an even number. So I can say my vector and I can validate if this, I can check if this is valid. I can add something here that says evaluate the false. I can see that it is not a valid vector. And if I do explain data on this, you can see the problems, and this plays into the structure that says by knowing I have a name, a number, and an even number, the path that I failed on was the even number check. I was said this was supposed to be a number. You gave me Bob. And this is in the third position of the vector that you passed me. So we can start to do other things, or I can say 42 and Bob and explain that. And we get a reason that says, hey, you told me you were expecting three things. I got extra input. I expected a name, number, and an even number. You gave me Bob, which didn't fit into any of those. So I start to have some rich details about how did this spec fail. You can do things about, I can do my map and I can say slash keys recon. I might be, I think I'm screwing this up. There's a way to say, hey, what are the keys that I expect in this map? Clojure specs are kind of optimistic about how it treats maps. It doesn't want to conform to the world. It just wants to know that and validate. Here's the stuff I care about. If you give me extra stuff, I'm not going to complain. It's just irrelevant to me. So Clojure's idea of maps is fairly open. So I can say, hey, I want to do a map that says valid my map. And then I can give it a map that says my vector. Question mark there. And I can see that, hey, the path was my vector and even number. And then if I change that back. What if I put some other key in here? Key. We can see that this validates. So I said my map requires essentially a key for my vector with this spec. So I have my vector. Rec_un means require this key but unqualified name. So drop the namespace off the keyword and just use the back part. So it is permissive about extra stuff. What you're doing is you're specifying the stuff you want in and not necessarily caring about the stuff any extra stuff. So it's a permissive check. But Clojure does pieces, and at the top I included the Clojure.SPEC defs, and Clojure gives a bunch of details about what a spec looks like. So as part of the core logic, here's a syntax for a function. Actually, right here. If I want to define a new function, I can say define, so define function, give it a symbol name, an args list, and a body. And so that is a perfectly cromulent function for me to evaluate and run. And I can say foo 3 and get back 6. What I can do, but defin is a Clojure macro, and there is a structure to this Clojure macro. So I can do some details about this gets into the parsing. So I can say, is this a valid body for Clojure? Let's move it up just a little bit. So I can say, is this a valid body that goes into the defin macro? And I can say yes. What I can also do, and this is where spec gets interesting. Some parts of spec get really interesting and not much talked about. So what I covered previously was the idea of being able to define specs and validations around certain structures. Clojure gives some of its core functions and macros specs. And part of that is when I say, if I want to define who, and put something in that wasn't supposed to be there, metadata and block string, and something else. I can take this, give me a wrong argument structure, and ask if that is valid.
Supposed to go to a meeting on the 6th, and I can't get up there either. So I just called in. It's like, oh well.
So we can it's wrong. Specs spec dot defs defin args. So we can say that this thing is not valid, and if we try to defin this, what we see is we tried to evaluate defin foo. We got a syntax error macro expanding. And we said, hey, docstring failed. It was a vector. And here's some details about like how did this thing fail? Docstring failed. Is it not nil or sequential at this point? So part of this gives some structure. And so what they're doing under the covers to get this is you can run a conform and it will tell you essentially if this thing meets the spec and what the spec parse tree looks like. So if I want to take this list, I can say conform this. And so what I get is, given the definition of defin args, can't jump to definition. But foo parameter x with a body gives me, hey, I've got a function named foo, and I've got my function tail, which is an arity1 function definition, and it has a set of params that's a local symbol x, and it's got a body, which is a vector of expressions. So there, I can also say, hey, I want to put some metadata in, and I can conform. Maybe I put it in the wrong spot. So there's a pre-post. So if I can do precondition checks, and I can say, hey, if I put this here, this is expected to be pre and post condition. I can put a doc string. And it gives me the various structures that I can conform to. There's also a form of defn. That's a multi-arity form. So if I had one argument, it might be X, and I can have X and Y, and I'm going to multiply X times Y. And I can say, okay, here's foo. And if I call foo with 3, I get 6. If I call foo with 3 and 7, I get 21. So I have multiple arities that I can do, but the idea is that the defn form has different structures here as well. So I can say, go do this. Pull in this form. That's the multiple. And I can say, is this thing valid? And it says, yes, it is. And then I can ask, how does it conform? And I can see that in this case, I've got an arity n. In the previous case, if I'm conforming this, I get a arity 1. So there's an or kind of thing here that says you can have one body. Oh, thanks, Andrew. Put the metadata in the wrong spot. That's what I was thinking.
Oh, you just missed the caret flag on it.
Flag. And so as part of this, I can say, look, I have arity 1 or I have arity n as part of a body, but it gives me, it parses my function structure in 2 different ways and gives me details about what is my function name, what is my function tail. In this case, I have a doc string, so a doc string shows up in that map of a data structure that represents my function args being parsed into a structure. And then there are cases where you can unform something. So I can say, if I can form my defn args, I can parse it into this kind of structure. And then there's an unformed function, which turns it back into Clojure data. There's a little bit of an issue here when we look at defn args, because if we looked at the original form, let's put it on some new lines so we can see. It was foo with a vector, so square braces x, and plus xx. The unform, there's a nuance to something in the way they did it with Clojure, where it's not, it doesn't turn back into the original form it does. There are known workarounds. I believe Jonathan Sharvit, who did data-oriented programming book, was a presentation here at one point. His blog talks about some of this stuff. There's some details here about how can you turn this into an argless unformer. So you can essentially take their spec that they've given in Clojure, and then there was some tweaks that says I can evaluate this. And I'll run through it real quick, but we can see the structure of the defn args is there's a name. It's a simple symbol. There's a doc string. There's some metadata around it. There's B's, which is a body. And then we could say there's arity 1, which is an args plus its body. There's an arity n, which is a set of bodies, and an extra metadata map, which is a legacy thing, but they spec'd it out. And so you can actually start to understand what. The other thing that's interesting about spec is when they give you these specs, or somebody gives you these specs, you can start to see things that you never realized. So when I was looking at this, it's like, oh, it's not really documented its legacy, but they've documented that you can add metadata to the end of your declarations if you have a multi-arity function. goal is not to use it, but you start to find interesting things by looking at the spec. But what we can do is, if we give our own override for def and arg so we don't accidentally break closures, we can you can give a conformer which says, how do I conform something, and how do I, like, if I want to manipulate the conforming after, and then how do I unform that for this? So the arg list, I can turn it back into a vector. So I do whatever there is and turn it back into a vector. So I can say, I want it to look the same as I unformed it. Let me come back here. So now if we conform, we can see we can get the same kind of thing. But if we conform and then unform, we can see we now have foo, the vector x, and then the body of x plus x. So we get the same thing back of what we unformed. So there's a relationship now between I can conform something, essentially I can parse it, and then I can unform it and take the parse tree and turn it back into the original structure. So this is where the parsing starts to get interesting. And so as I kind of did it up there, I can say, hey, here's foo with multiple bodies. So, and then we can see that this one has BS with an arity 1 and args. This one has BS with arity n and a key of bodies that's a vector. So now I start to see and get, and this plays in with that explain. So this is how you understand the path for the explain. But it also gives me a data structure that I can also do some assertions on via spec, but also be able to have a structure I can manipulate. So instead of just manipulating code as macros, so when you define macros, there's a way to define macros because you implicitly know the structure of the macro, but you can also, what this makes interesting is starting to codify the structure you expect in the macros and working against a parsed version and treating that just using the map structure that it gives you, working with that, and then turning it back into what you want. So I've got a couple of examples for play, and I'm going to start slowing down some. So feel free, this is where it gets weird, and I expect more interruptions, and feel free to ask questions if you have stuff. So what I can do is I can say, look, I have a macro. I want to, so in Clojure, if you do a def n, it's public in that namespace. If you want to make it private, it is a def n minus. But so if I'm working, I may have public in a namespace, but I may have something I want to signify as part of a public API that I want to consume. So if I'm writing a service in Clojure, there might be public, but there might be public things I want to expose. So when you build a web server, in a lot of cases, you say, I've got some handler that points to this function here. The idea is that even if you were in any other language like Java or C and some of this stuff, or some of these functional languages, you have things public, but that doesn't mean they're necessarily the entry point functions to it. So maybe I want to be able to signify the idea that, yes, these are public, but this is really part of an API that I expect other people to be using from an outside usage, or I want to expose through a web point. So I can maybe I give some extra function declaration syntax that says, look, I want to be able to do this and mark this, and I'll add some metadata to the function that says, instead of making you remember to put metadata on each of these functions, I can just say, look, if you do a def API, we'll give you some syntax that does this for you. So I can, instead of writing my def in, I can write def API and just write it like I would any other function, but have my def API do some augmentation to that declaration from a macro perspective. So because this is just code and it is data that represents our code, I could go through and know that the first body is the name. The second one is this. I can also just piggyback on what Clojure's done. So anybody who defines it normally as Clojure would support, I can support that function too. So I don't have to do all the nitty gritty parsing to make sure that I can support whatever Clojure supports on a def end. So if somebody just wants to change this from a def end to a def API, we can say, hey, this works. And you're now making this extra public. So then what we can do is, because we have conformed args, so if we look over here, we can say, hey, I want to update the meta key in here. If there's no meta key, it'll add that entry. If not, it'll add. So associates like add this key. Let's knock this down a little bit. It's wrapping. So I can say, given this map, I want to put the key public API in that map that has the value of true. So I can now say, give me anything, and I'm going to just augment your metadata on that function. If you gave me other metadata, I'm going to add more to it and make sure that this is marked as a public API. Once I'm done messing with this structure, so I can now mess with this structure on the side, that's name, foo, BS, arity, and bodies. I can mess with that structure instead of messing with this structure and making sure I account for all the cases. So I can update the meta key in that structure and add public API as true. So if I evaluate this, we can do one just to FN. And we can see meta of foo. This is a special thing that says look up this binding value of foo and inspect it. So I can look at the meta of this, and I can see that Clojure adds its own metadata. What line was it on? What's the column where it was? What file was it in? What's the name? What namespace was it declared in? What's the argument list? I can say, hey, I want a def API. Macro expand is a way to inspect what the result of running the macro looks like. So don't evaluate it yet, but do the expansion without evaluating it and give it back to me as data. So now I can see turning def API of foo gives me the foo of foo x plus xx. Now it says, look, I can def n foo. Oh, here's a map now. I now have a map for metadata in there, and here's my body. So I can macro expand that, and I can also I can evaluate this now as def API, and if I ask for the metadata again, here was the metadata before. We can now see that I was able to know, by knowing that there was a potential key of meta in there that the def-n supports as its specs, I can go add my own key in here and work with that instead of trying to pick out and stuff. So it gives me a richer parse tree structure from validating it and conforming it with Clojure.SPEC. And once I have that structure, after I've changed that structure and manipulated that structure, I can then unform it using def-n args and result in a structure that says, okay, now when I'm going to evaluate this, when I'm going to return this, I'm going to say I'm going to prepend a def-n on that. So this will now look like a def-n function. But I've changed my structure under the covers without you needing to know it. And I was able to lean on all the work that the Clojure core team has done in their macros for def-n and specifying that. And I can not have to reinvent the wheel, but I can take everything that they've done and use their structure, their parse tree structure to my ability without needing to know that. Does this make sense? I'm going to pause for questions before I go on to some further examples. But I want to kind of pause and let people ask questions.
So this makes a lot of sense. I was going to ask, what's Are you going to show us what happens with a recursive function, or how does it work when you're calling other functions inside of a definition? Does it
Well,
keep
right
track
now
of
it just evaluates the fact that you've got
No, if you, I'm sorry, not the macro or not def API, but like if you have a recursive function and you you conform, you get the function conform for it. Is there any way of like knowing that it's calling itself inside the body, or is it?
So when we conform and unform here, we
Oh, okay, I see. Yeah, so it's
and it just looks like it because it's not actually doing any evaluation at that point. It's just
okay.
reading in that structure, parsing that structure, and then working against that parse tree. So if we look at, if we'll go back and just do, let's see.
Because I was kind of wondering if it's possible to get like a spec where you could determine if a function's tail recursive, right? Like kind of like a higher order.
You might be able to write such a spec by looking at the body, and then by knowing the fact that you've got the body. Like I go look at the bodies, I've got args, and I know that it's going to be a set of args with a map of args, and then a body that's a vector, and I could, in a very dumb version, I could find that it is just always look at the last expression in there and see. But again, that doesn't give it, if you have conditionals and things like that, doesn't tell you if it's tail recursive per se, but you have the structure there, and you could potentially say, okay, now let's go try and unform some of these other things if I know what the expression is.
And
if I have a specific format, I could potentially just write a spec against my specific format kind of thing.
Is it possible? Can you do and this might be a stupid question. I guess you probably, so you could do, okay. So it does sort of do a recursive. Okay. No, I think that makes sense. I was looking at the, like, I guess I was wondering if you could do a recursive, conform on every function symbol inside the body, or if that's even.
Yeah, you'd have to know that it's a function symbol.
Yeah, that's true.
To understand.
Fair enough.
So that's like if you have a known structure, like if you have a tree structure and you want that's explicitly like a tree with that you've spec'd out, you could probably do some other advancements because you've got a very known and limited parse structure.
You could probably look for the name. I mean, if you're just looking for like a self-recursive function, you could probably look for the name, just like search for the name in the body and figure out. No, it's cool. I'm trying to think of like other applications. I mean, so I like F# and I know that when they gave us a decorator, because this does remind me a little bit of decorators, they that would allow you to tell if it's a function's tail recursive or not. I really was happy about that. Just from like a, code quality point of view.
Yeah. And so some of what we've been experimenting with in work is part of this is we're kind of writing our own framework a little bit, but we want to be able to say like, hey, we want to know what our like if we're going to write stuff, we might be writing everything in Clojure. We might be throwing it in the core namespace for a project, but as part of like an application service component, like as a service thing, there are certain things you make public that are service, even if everything else in your code base might inherently be public by default. And you might be like, I'm not going to do it, but I do want to mark that this thing is part of my service API. So this was great. One example.
That's a really good application. Yeah, that's cool.
I can say, you can give me any valid Clojure function structure, and I can just go and do stuff with that. And I don't have to worry about learning how to reparse this spec. If it's something specific and I want to limit it, maybe I say, hey, I've got a limited version of a declaration that you can give me. But I know if I want to turn it into just a regular Clojure function, I can do some modifications, get it into a structure that looks like this up here, or one of the other ones, and then unform def and arg. So I'm going to say conform to my special declaration, do some manipulation of that structure, turn that structure into another structure that says that meets the def-n arg structure, and then I can unform it and turn that into a def-n declaration. And so it gives you the ability to work off your code as data, but macros before was just like, hey, I know I've got a list of things in a certain order, and it's kind of abstract definitionally, and if I do something wrong, and maybe I forgot to drop the first and not pull off the rest, what it allows us to work with is a more formal structure versus just iterating over a list of items and making sure that those things match. So this was one example. Is like, look, I just want to mark everything as part of my public service API. To build off this is why I was pausing, is maybe what I do is I have my def API args, and it looks a lot like def-n args. And I can say, look, the def-n args, come back up here. Right here. So def-n args says I have a name, I have a docstring, so I have 0 or 1 docstrings. I have a metadata, which is 0 or 1 maps. And then I have some bodies. Well, maybe because it's a public API for a service API, I want to say, look, no, if you give me this, you can't accidentally be lazy and not give me a docstring. So instead of this being 0 or 1 per spec, I can do API args, and I can say, hey, this docstring is a string. And or I could do I can even force it further and say, you have to give me a non-blank string for my docstring. So I can define a spec that says def API args, and then I can say, does this, if I were to write this body of def API v2, does this body conform to that spec? And it says, nope, this is invalid. If I do an explain, I can say, hey, I got this point. This sub X failed. I was expecting a string from my docstring. You did not give me a docstring on this. So then I can say, oh, here is my docstring. Very much. And now I can say, hey, okay, now try and explain this. And I can see success.
Could you do something where, sorry, not to jump in. So if public API is true, it checks if there's a doc string. And then if it's not true, it checks.
Well, this is part of just saying, look, what if I'm going to give you a def API function,
Sure,
that you're going to, or a macro to write a API entry point kind of thing, a service API function, then like this is the version 2 of creating a def API thing, is like, look, I don't just want to just mark it as metadata. I want to enforce when you write something, you have to specify a docstring, otherwise it won't do compilation, macro compilation, compile. You can't.
Sure.
That's an invalid macro. You have part of the requirements of this is it has to have a docstring. So part of this is you can do spec has an fdef, which means you can take a function definition, give it its args. In this case, we're saying the args is our def API args, which looks like the regular function, but says instead of being 0 or 1 strings for a docstring, it's going to be a non-blank string. And then the return type is any because it's essentially a list. I don't care because it's a macro, and I'm going to return more code. So what I can say now is I want to conform this instead of the previous one, which was conforming it to the def-n args. I want to conform this to the def API args. I'm still going to associate the metadata to it. And then I'm going to inform it to the official defn args. So then I can make sure it's in a structure that can be passed and augmented to defn. So I can say here, and I can expand, macro expand this def API v2. And we see that it said, hey, failed string. It doesn't have it. If I macro expand this, I must have a doc string. Cool. If I evaluate this, and now if I look at the meta, I can now say, nope, nope, hash quote, single quote. And now I've got doc string in my metadata because I forced the writers of the code that use this def API macro, aka function. It's really a macro, but it looks from a usage size, you don't know that it's a macro or a function, but it's a built-in thing that I have as part of adding syntax to the language. I say, hey, you have to give me a doc string, and now I also mark public API as true. But what happens when I macro expand this is it looks like defn foo, I must have a doc string. Here's my public API. And so I can essentially start to add stuff that says, here you go. I don't just want to, from you, you've just done your def API. If me as writing tooling and framework for you, I can say, look, I can enforce doc string. I can enforce the fact I can auto generate and make sure that everything here gets tagged as public APIs with some metadata. Now we have a doc string. You're now forced to, when you start doing this, you're now forced to go and make sure everything has a doc string. If you forgot, you can't do it. So you can start to say, what does my spec look like? So I took the basic defn spec and I said, okay, let's augment that and change the doc string to make it required. I could say, hey, metadata maybe needs to be required, and you have to give me this other key as part of metadata. So there's some stuff here you can start to do with parsing, creating new syntax, and using this to parse. I will pause here for some further questions and answer. But essentially, the difference between the last one was instead of just conforming to defn args, I conform to my def API and make sure it meets that spec versus not. If I ran and just tried to, by doing the fdef, when I try to run this, I get a syntax error instead of just a failure or an error, but I get the part of the explain string with the path that says, hey, I failed at string expecting doc string, but I got a vector that was X, which looked like that was my argument list. I didn't get a doc string. So this doesn't work, but it does when I put a doc string in. Questions on this? Okay, I will go on then. Hearing none. So then there's a third example, because this is structure and this, I'm going a little bit further, is because these are essentially public APIs, their service entry point, their service points, service API calls or something. We want to make sure that when you write this, instrumentation is there. And we can say, hey, can I make sure that you write instrumentation? So this is just, let's see what, if I give a body of something, like here's the body of a function, which is the args and its body. What does this look like? Just to give it a little bit more specific. So it's a map that, so there's an args. Args has a map with some vectors of args, and there's a body. So I start to tackle this. So now I can say what I want to do is whatever body you give me, I want to put some code around that for instrumentation purposes. So this is a little bit more macro-y and a little bit more macro syntax, but the idea is I want to take an args body and pull out so this is a conformed args body idea that says, if I take this structure What do I what can I get out and what do I do? I want to get the arg list out and know what my args are. I want to unform just the arg list part. I want to essentially unform the args list part, and by saying, okay, unform this so I can understand what they passed me. In this case, for this example, it was just X. I want to get the body out from the args in the body. So I have the args here, and I want to get what that is, and then I have the body here. So what I want to do is I want to give you a new body. I'm taking a name so we can say what the name is, but I'm gonna hide the REPL stuff for a minute, but I can say, look, my new bot. This is what the structure of what I want my new body to be. So if I have an existing body of a function, I'm gonna give a do block that says I'm going to do some instrumentation. It's just print line, but I'm going to say, hey, I want to print line given the name that I got in and what the unformed versions of the arg list looks like. I want to print the fact that I'm entering this function. Then I'm going to put my body that you gave me into a do block so it runs all to completion and binds whatever the body you gave me, whatever the result of that expression body you gave me was. I'm going to bind this to a variable res. Res with a bang at the end is a Clojure macro thing that gives me a unique symbol. So there's a function for gensim, so I can say foo, and I can generate a symbol foo, and then it puts some unique stuff at the end, so to avoid name clashes. So this is part of a hygiene piece of macros where I don't want to use a name that you might have done. So I don't want to contaminate. If you called something res in your code, in your stuff, I don't want to somehow accidentally overwrite and rebind what you had for res and contaminate your res with my res. So the res hash is just kind of shorthand for go generate me a symbol starting with res. And so it'll generate something like this. And I can say, okay, now I've got I can bind the result of executing the body into this res, because that's what somebody told me that was going to be their return. I can capture that after I've run it, print that I'm leaving the function, and then return the evaluated body. So this is a list macro trick that means I can evaluate this part once, bind it to a new thing that's going to be hygienic, because I only want to run this once instead of putting the body here again and possibly running it twice. So I want to make sure I only run this once, get what that value is. I need to make sure I print, because if I just did println do body println, well, I executed your body, sure, but I've thrown out your return value because the last expression in my body of my function is a println, which returns nil and does the side effect. So I don't want to change what you were going to return, but I want to augment my function. And then I can say, look, this is what my new body looks like. I want to wrap the existing body with this stuff, and that'll be my new body. And I can put that back into my args plus body. I want to evaluate it, not just. So now I can say, okay, give me some function. If this is what the body looks like, I have args plus body. And I'm going to get that into the conform list. So if I just evaluate this part, you see that this looks like this args body. So if I just want to test what this would look like, I can say, hey, wrap, enter, leave. So args went from args. Those stayed the same. But my body now has a do. There's a Clojure core print line call that says entering function some fun arguments X. So this some fun was the stringified name, that the symbol that passed in. But this X was the unformed arg list. So I can kind of say, look, you declared X. I've got more detail here from my parse structure, but in this case, I unparsed it so I can. I unparsed it so I can give it how it looked when it was being called. So the arg list looked here. I want to print it like this, where it's the vector with an X in it instead of the args of local symbol X and things like that. But then you can see, look, I got a let. I create a binding for it, do my X plus X. The evaluation of that gets done, gets bounded to here. I print line, and my res looks good. So my body looks like I might expect it to. And if I have two values of an X and a Y, okay, my X and Y unforms correctly, and it looks like how I would want that body to be called. So that's kind of, at that point, because these are data, you can start to write function. Like this part is not necessarily macros here, but it's functions which generate something to be used in a macro. So it returns a quoted result of this without evaluating this do. But I can say, look, I'm working on this data. I want to create a new thing that I can stick into the new structure. And so down here, I can say, okay, now I have API v3. It's still the same API args, but my v3 version says, okay, I'm going to pull out names from the conformed args so I know what my function name is. We do our update meta that adds public API of true into the metadata. But now I have the bodies, and I want to update the bodies. And so if the bodies starts with arity 1, then my new body BS's is going to be arity 1, because that was what the first thing I matched. And then I'm going to wrap enter and leave for this function name against the second part of the body, which is the previous old that argument list, the unconformed argument list that we were just looking at and playing with wrap enter and leave. If it's an arity n, I have a whole bunch of bodies, and then I'm going to map through each one of those bodies for the different arities, and I'm going to wrap each one of those with an enter leave and turn them back into a vector. And then I can then say, okay, now I want to unform this to def n args, and I have a b3. So now if I say, look, I have foo, I must have a docstring x. If I want to macro expand this, we can now see I've got a def n foo. Here's my docstring that I enforced. Here's my public API. What you gave me was just plus XX.
Sorry, Proctor, ignore that. That was me correcting a mistake of mine. Go back to what you're doing. Pay no attention to the little gnome.
So now what I've gotten is you wrote a function without instrumentation. Because I've got this structure and I can manipulate the structure and I've got a parse tree, I can manipulate that parse tree, add in other structure and say, look, I'm going to make sure everything here is instrumented. So you gave me plus XX. I'm going to just make sure that this actually works. So let's see what that happens. So I have def API v3. It says I do a thing. And I can say, what is my metadata for my external API function? And I can say, here's my doc. I do a thing. This is an important doc string. It is public API. So I get all those things. But now I see when I call 1 and 2, I see entering function, my external API fun XY, that I'm leaving the function, my internal X, and then I've got 4. So I start to have I get my return value and I get my instrumentation, and we can do extra things like, okay, well, instrument, and then maybe there's something else that says put in some logging instrumentation context. This is a new thing, so generate a new request ID and put that into all instrumentation context. There's all kinds of things you might do around this that says when you write a function, you can just write a function, but when you want it to be this kind of thing, we can help build up tooling for you that says this is what it means to be a service API function. You have to have a doc string. We're going to ensure that we're not going to rely on everybody to, out of good practice, make sure they instrument and put a span or some logging statements around the entering and exit. If we say we're going to all use honey badger, I think, or honeycomb or honey badger, or any of these other kind of things, whatever we say in our company or something, we can do. Like, this is our conventions, and you can just write the body, but don't worry, because of the macro system, we can parse a normal function body, give you enhanced features sets or a restricted version of a function body, enhanced feature sets, and put that into the code so you don't have to write it. We can write it once as the macros and add these add a new language feature to you as part of a framework library by using Clojure.SPEC to do this parsing. So I believe those are the last examples. Yeah. So part of this is because I have this structure, I'll just go back here for a little bit in 6.8. Because I know what my function structure is, I can say, hey, in this case, there's a 1 area 80, so I only need to do that body. If this is an arity n, I know I need to map over these things and do this for every single body that you gave me to the function. But I know that you can give me one or many because I'm just piggybacking off, again, I'm piggybacking off all of the work that the Clojure core team has done when it comes to defining functions. So happy to answer any other questions about spec or some of this parsing stuff and go into a little bit more detail, but that is that was trying to show you the idea of different ways you might enhance these functions and take advantage of macros with different abilities and build on these ideas to use a spec for parsing and working against a parse tree instead of just a list of values. Because it's one of those things that I had seen spec came out 2013, 2014, I think. I believe this stuff was all available with it at the same time, but it wasn't until relatively recently, in the past year, maybe year and a half, if that, it might have even been under a year, that I realized there's all this conform stuff. There's, like, I've heard people talk about, yo, you can do extra stuff with spec. It's not just validation. And then I stumbled across some of this parsing stuff. I was like, oh, that is super powerful. It means if I want to write these macros, it gives me more structure to work with and formalize that structure that I can then work with. And so wanted to share that off to people and possibly spark some ideas, because it's an interesting concept of that you get both validation. Not only do you get validation, but by giving you validation on some stuff, you actually get the ability to parse and unparse these values based off that structure and that path that you get.
I have a general question about spec. I like this concept of the conform unconform. I did have a question. So when you're just using plain old spec, is it able to inspect what's being validated in order to either pick one root? So I'm thinking, like, if you have like a tagged union in Clojure. So if I have like a tag which is like type, it's either an int or a string, could it check the tag and
so here's kind of my tag union.
Okay,
non-blank string or number.
So it'd be or and, so it would okay, so that makes sense. So okay, I think I missed that.
I can then do an SFDEF something, That is a, and its args are non-blank string or number. Its ret is any, just it'd be, I think, any question mark? Yep. So I can define that, and then I can do fn and I can, if I evaluate the, oh, that's an anonymous.
Okay.
Defn. So I say, hey, defn this. I can do 32. Get that back. I can do
Oh, nice.
something. You gave me a string, but if I go again, kind of as I said, if I go now, it's a vector. What did I?
Because I was thinking something like you would have like one. So you could say like, if you have like a collection of tags, right? So let's say that I have a tag, which is, something can be either a name or an ID, right? So I could have a tag, which is a literal ID, and a tag, which is a literal name. So I could create like a spec that basically checks to see if it's a tag, if the tag is ID. And then if it's ID, then it checks to see if it's an integer. Yeah. And then if the tag is name, then it checks to see if it's a string. So I guess that would be the or combinator for do you call them combinators, or are they just kind of like
other spec constructors? But
yeah, sure.
Spec constructors, clauses, kind of
Okay.
depends on the person.
Cool.
fdef. Right. Same thing.
And can you use spec to generate data?
Yeah. So spec.
Okay.
I don't know how you can use it. I've heard differing levels of advancements about how you can use, of how well it works for generating stuff and how well it does shrinking.
I was
But
thinking like
there is
Conform, you could generate functions, man. Like that would be pretty cool.
Yeah, so you could do essentially spec.
Oh, okay. Yeah.
And I can say blank string or number. I might need
Nice.
to pull in another namespace for
Oh, that's fine.
but yeah, so there's some stuff about generating stuff. And but yeah, if you get, I don't know what I'm breaking in my SFF here. Because it's not actually doing the validation. Maybe it's only on macros. I think maybe it's only on, I think maybe it's only on macros. Because there's instrumentation that it can, so you can turn instrumentation on in a function too and say, okay, I want to instrument and now let it work.
You can also set pre and post clauses directly in the defn body, like right after the vector arg list.
Yeah, so if you do a def macro, it does the structure validation for you when you're doing the macro declaration. If you just got it as a function, then it does not and evaluates it, but you can do S. Is it instrument? I thought it was instrument.
I don't remember.
There's a way to turn on instrumentation, so you can say, hey, maybe in my dev build or something with a flag, I want to turn on, or in all my tests, when I run these tests, go validate the function of all these cases match it as well. So I can do.
Nice.
It's kind of the turning on precondition checks and post condition checks. There's also another thing.
Can you use it for like static analysis in that case? Like if you just have like a bunch, I mean, so I was asking about like the tail recursion. So like I was thinking, if I had a Git build where I just want to run some static analysis before I, when I build it to make sure that all my recursive functions are tail recursive, then I might want to run that like, I guess using the instrumentation function.
The other catch is I can do with an fdef, you can give a function keyword as part of fdef and give it a function, and it will say like correct, and you can essentially do some comparison that says I've almost got dependent types now to some extent.
Yeah. Makes
well,
sense.
part of it is it's a predicate, so I can say, hey, it's my inputs might have dependent types that say, look, if you give me X and Y, I can say if my list is, if I got a list and a list and my return is a list, I can make sure that they're all the same type, but I can say, look, I've got a function here that says, here's how they relate. The length of my X plus the length of my Y equals the length of the return. And I can start to do some dependent type behavior kind of thing and relate the inputs to the outputs as well. And say, if my inputs were you did divide, if my input was a 0, I'm going to give you a nil return or something and put a relation between. So there's this you can give a function that gives you the relation between the inputs that you got and what your expected outputs are going to be too, and refine those specs even more by knowing. So instead of just saying, hey, my return is a list or a list of string kind of thing, I can say, I can start to relate the inputs to that.
Cool. That's fun.
But yeah, so it was the there's some neat stuff in spec that flies under the radar a bit because it's a lot of, hey, validation. And so when Claude asked about presentation, like, yeah, I can present on like this little piece, which is lesser known, but you get a glance at it. It's like, ooh, there's some interesting things I can do because it makes parsing it easier. It does the parsing for me, and I get a structure I can work on.
Almost like it's like a cheap reflection in some ways, like, which is, I mean, like in a Python or something like that. Yeah.
I don't know that it's reflection because it gives you your structure. You're getting your structure out of it as well.
It's used in the same way that like a typed language might use reflection in sort of a worse way, I guess.
So I can see, hey, like if we want to talk reflection, and this is kind of where the tagging with metadata comes in, is like, once I know I tag it with metadata, I can say, hey, go find me in this namespace, or I can do, there's a I can say all namespace. So here's every namespace that's loaded. So I can do something like, go get all namespaces. I want to map cat as interns. And this says, okay, here is the identifier and the essentially the binding there. I can do map second. And get all the binding names, and I can say, okay, now let's map meta. I can evaluate all of them. And it goes and gets me this, and I can do now filter public API. And I can get back my items that are tagged with public API. So I can start to do like to talk about the reflection by doing some of this stuff like, hey, I'm going to tag it with metadata. I can look at every namespace that's been loaded, go find everything that's been interned, essentially defined in that namespace, pull the metadata off each one of those, and then go find these things and filter out, go find the ones that actually are marked as public API. So I have my external API fun and foo. And these essentially represent my two essentially service API things that I've defined.
Cool. Oh yeah,
But-
yeah. So that's really nice. So there you're just looking for, okay. No, that's
yeah.
really
So,
cool.
but like, because I gave you my def API under the covers, I'm saying I'm tagging this, or I'm doing this other stuff. So not only am I tagging this, like not only am I adding instrumentation, but I'm also going and tagging so I can then go find everything declared as a public API. And maybe if it's, maybe I can also then go generate an HTTP server.
Yeah, or
and
I mean, you're
generate,
just
like,
generating
figure-
documentation. Yeah, I mean, like,
generates document. Well,
Yeah,
the other idea is you go generate an HTTP server or a
Mhm.
CLI that can introspect off these metadata that say, look, here's my args, and I know like these are going to be JSON. Like I'll just say it's everything you're going to send me is a map, and I'll know how to destructure that out of these things, and then create a route that maps to this var handler based off the function namespace and name or some other kind of name qualifier, and generate a route based off. You can go hit root / my external API fun as an HTTP thing with a post, send it a body that with an X and a Y that we generate, and I can go generate routes, and you can start to have a framework for how you define stuff and never actually have to define an HTTP handler or go generate CLI commands and things like that. If you say, by writing this stuff that forces you to annotate it, and you say, look, this is a separate kind of function, I can now give myself additional tooling to find this stuff based off reflection and some other stuff, and do introspection on this.
so I think like ASP.NET does a lot of this, but in a much clunkier, like it's nice that you can just sort of grok what's going on, like in this case,
Yeah.
sort of, or build it up as you like. So very nice.
Yeah, some of this is not anything necessarily new across the history of programming, but it's kind of the examples of being able to say, hey,
Yeah, that's awesome. I mean,
not only can I write language extensions for me to use as a framework or for somebody else to use, and then you can say, well, once I know how that does, if I want to go do things for reflection or other stuff, I can then not only just I can tag them as well as make sure everything's instrumented or something, but it kind of puts you behind. You use it,
and you can hack it, right? Like it's much more hackable than like a lot of these. I don't know,
because I'm working off an
yeah.
actual parse structure that I've gotten now. I gave myself, by putting a spec on this, I gave myself a parse structure that I can actually work against, instead of just being like, if I were to try and do these with other macros in Lisp, it becomes a pain before I realized I had this power with Clojure.SPEC to do this parsing. Because it was like, okay, double check which argument position am I on? I've done a first and a rest, or I've done the first and the second, and now I need to get this thing off, and is this supposed to be in position 3 or 4? Well, that depends on if there's this other thing here. Like, is this thing, like, walk through and say, is this a vector? Oh, wait, no, it's supposed to be a map if it's metadata. So that is, like, It can be a string, in which case it's a doc string. It can be a map, in which case it's metadata, or it can be an argument list, or is it a list? Like, is it a list or is it a vector? If it's a list, it's an argument list bodies. I don't have to do all those conditional branching stuff. I can encode it and do that parsing and take that out of my macro part. Not do the parsing in my macro anymore as well, and just use the structure that I want. Because yeah, before it'd be, if I was trying to do this stuff, all the conditionals that you declare would be littered across the macro, because I'd be individually checking each spot that says, okay, now try docstring. Okay, try docstring. No, okay, give me back the docstring piece if so, or the args unmodified if not, or the modified args depending on if there was a docstring there. And it kind of becomes like, if you look at some of the Clojure core stuff, you can see it's like, try parse docstring, and it returned you a tuple that was a docstring and the rest of the arg list, either updated or untouched, depending on if it found it was a string in that spot. So that is all I have. Any other questions?
I tried to find your dot files. I don't know what's your username in GitHub, Proctor. Can you share your dot files link if you have in here in the chat?
Yeah, I can drop it in the chat in a minute.
Yeah, sure.
Any other questions? Then I will go stop sharing and we can talk about some other stuff potentially. Or if Claude has joined back on, this is when he gets to enjoy his. We can do the after talk. But I am stopping the recording, stopping the sharing. Stop recording.